Hello, this video is the first video for Trig and Advanced Math topics. And today we're going to start to review some of the items on your pretest, going back to some geometry basics. So in this video, you will see learning targets A, B, C, and D. And this is Unit 1, Folder 1. The first two learning targets we're going to start out with are 1A, I can determine the types, key features of, and measurements of angles, and that includes angles and triangles. And I can use complementary and supplementary definitions to find missing angles. So let's begin by chatting about what is an angle, what are the parts. So an angle is formed by two rays, and a ray is this piece here that has an end point and then an arrow on one end. So it keeps extending in this direction forever and ever and ever. But it does have an end point over here. Where these two rays meet is called the vertex of your angle. If you have a shape, a polygon, like a triangle, for example, all three of those points where the segments are connecting, if you refer to them in the plural, they would be the vertices. So if I talk to you about vertices, that's what I'm referring to, where those, the corners of the shape, essentially, where the angles are created. Also this year, I should just mention, a lot of times we put the little swoop in here. We might call that angle X. You're also going to see the symbol theta. That just represents an unknown angle. It's a Greek symbol, so that will come up. Just a little vocab review. You probably remember most of this, but two angles that are on a line, those are called a linear pair. These two angles, X and Y right here, would be considered a linear pair because they both sit on a line together. Their sum is 180 degrees. Two angles whose sum is 180 degrees, those are called supplementary angles. We're going to go on a journey through trigonometry, and we are not only going to focus on trig in terms of degrees, but we're also going to learn about something called radians. And so their angles can be supplementary, and we can deal with that with degrees, but we're also going to look at what that means when we have radians. And that gets a little bit trickier because everything's in terms of pi, and there are lots of fun fractions. So don't worry, we'll get there. But just so you know, this word will come back to us. Similarly, two angles whose sum is 90 degrees, aka they make up this right angle, are called complementary angles. My high school geometry teacher always made me remember that complementary means 90 because it is always right to give someone a compliment, and it makes a right angle. So it's pretty corny. But I think you guys know I love a math pun, so it helps you remember and helps you remember. So these two angles, A and B, they are forming a right angle together, and we know that because of the right angle symbol. We can't assume it's a right angle unless we see that. Those are complementary angles. So here, let's put that sort of concept into use. We have an X sort of shape, and on this X shape, if you look at angles 1 and 2 together, those two angles are a linear pair because they're sitting on a line together. So those two must be supplementary. The same with angles 2 and 3, and the same with angles 3 and 4, and 4 and 1. They're all supplementary. If you recall, we have angles directly across from each other like 1 and 3. We would call those angles vertical angles. You could draw a vertical line between them. And vertical angles are always congruent, congruent meaning equal. Okay, so 1 and 3 are vertical angles, as are 2 and 4. So let's say I told you angle 1 is 102 degrees. So then we would want to find the rest of the angle values. Well, you know if angle 1 is 102 degrees, then angle 3 is congruent, so it must be the same measure. And then we said that angle 1 and angle 2 and angle 1 and angle 4, they must add up to 180 degrees. So 180 minus 102, that would leave us with 78 degrees. So that's one way these measurements can be helpful for us. Sticking with that first learning target, 1A, let's use that in reference of some triangles. So scalene triangles, those are triangles whose sides are all different measures or different lengths. And isosceles triangles, those are triangles where two sides are congruent. So you can see here, these two sides would be two congruent sides. And then the base angles, or the angles across from these two congruent sides, those also have to be congruent. If they have the same symbol, that means that they're the same value. So those two angles are congruent as the side lengths are. Maybe that's 10 and 10, and maybe that's 70 degrees and 70 degrees. Okay? And that helps us find the missing angle if we needed it. The equilateral triangle means that all sides are congruent. So those three side lengths would be the same. And if all the sides are congruent, then it's also equiangular, which means that all the angles are congruent. Well, if you recall, all the angles in a triangle have to add up to 180 degrees. So if I have three angles that add up to 180, each one is 60 degrees. Again, this will be really helpful for us, especially when we start to look at the unit circle. If you have a right isosceles triangle, well, you know this angle is 90 degrees. You know the two sides are congruent, so then these two angles must be congruent. So if we know that all the angles in a triangle add up to 180 degrees, well, 180 minus the 90 degrees we already have gives us 90 degrees left over. And if these two angles are the same size, we cut that in half and we get two 45-degree angles. So that makes one of those special right triangles a 45, 45, 90 right triangle. We're going to look at those in the next video. Then we can have just a regular old right triangle with different side lengths. That's where we can start to use Pythagorean theorem to help us find some different side lengths and angle measures, or SOHCAHTOA, or we can use the 45, 45, 90, and 30, 60, 90 concepts. And again, we'll look at those things in the next video. We'll look at Pythagorean theorem in a minute. And then the non-right triangles, those are acute triangles or obtuse triangles. To solve those, you need the law of sines or the law of cosines, which you may or may not have gotten to in geometry, but we will get to that this year. All right, your third learning target is I can find missing angles in triangles. So I've given you this picture here. First, let's just assess what we know about the picture. We have two right angles here and here. So y and w are part of a right angle. So we know that they have to be complementary, or that y plus w has to equal 90 degrees. We also know that this triangle, is isosceles, this one here, meaning these two sides are the same, so these two angles are the same. So that tells me right off the bat that x is equal to 68 degrees. So now that I know that, I want to go ahead and find w. Because I know that three angles in a triangle have to add up to 180. So 68 plus 68 plus w, that must equal 180. Well, if we do some quick math here, 68 and 60 is 120. 8 and 8 is 16. So 136 plus W is equal to 180. You might be able to do this in your head if you're, better than me, but I'm just going to write it out here. So that would leave us with 44 degrees for W. And fill that in here. Well, we said y plus w has to equal 90, so y plus 44, now I can substitute that in, has to equal 90, subtract 44, y is 46 degrees, figuring out so much, and then lastly I want to find z. So I'm going to use that same concept again, that, different color here. We have the right angle in the corner, so 90 plus 46 degrees plus z has to add up to 180. Well, 90 and 46 is 136. If we subtract 136, we already did that math. So z is also 44 degrees. And there you figured out all of your different side lengths. It's not a coincidence, if you remember, that these two angles here are congruent, and that's because they're alternate interior angles. These two lines that are making up the base of the shape, those are parallel because there are two 90-degree angles here, so we know they're parallel. So when this line here, this is a transversal, intersects it, it makes two congruent angles on either side. Okay. And actually, maybe I messed up this problem. I did, because these should also be congruent. Oh no, I'm lying, because this isn't parallel. Ignore me. We did it right. See, I'm bound to mess up these videos all the time, so you just have to bear with me. So we know y is 46 degrees, and z is 44 degrees. So you can use all of these vocab terms to help you find missing angles. And then lastly, just a quick refresher on Pythagorean theorem. So first of all, we should know what it is. A squared plus b squared equals c squared. C has to be the hypotenuse, which means it's the longest side. A and B are the legs, and they can be either side. So let's look at our example here. If I set this up, I'm going to have x represent A, 12 represent B, and 13 has to represent C. It's across from the 90-degree angle. Then we have x squared plus 12 squared equals 13 squared by substituting that in. So x squared plus 144 is equal to 169, or x squared is equal to 25 if I subtract. Taking the square root, x is equal to 5. The reason I'm not saying x is also equal to negative 5, which was a big portion of Algebra 2 that we talked about finding the zeros, is because we can't have a negative side length, right? So when we're thinking real world, remember everything has to be positive. So x is equal to 5 is the answer we want. That's what we call the principal root. And we've solved for the missing side using Pythagorean theorem. So this would work the same way no matter which side you have. You just have to substitute them into the right place. And then solve your problem. You're always following order of operations, so square, then you add slash subtract, and then lastly you take the square root. All right, so hopefully you have gotten all of this down in your notebook. If not, go back, rewind, fill in any gaps, and on the left margin of your notes there in your notebook, if you have questions about anything, jot them down or circle or highlight them in a specific color so that when we come together as a class, you can ask those questions. And then once you feel confident with that, we can go on to the practice and the quiz for the day.